First module of the semester. This is an 8-week course. This module is very extensive. A lot of stuff that we talk about will be everything that we do each week in and out. So when you watch my live video, you'll see, especially module 1, how we start using source code repository. We're using continued integration. We're using deployment. We're using all those strategies, and those are all the things that you must do in order to pass this class. So, moving on. Let's get started, guys. We'll talk about Git, what's GitHub, what's HTML, and what is a project. So what's source control? Source control is pretty straightforward. It is a repository to hold source code. So think about websites like Facebook, Instagram. Instagram is an app. Snapchat is an app. Think about NBC.com, Comcast. All these places, what do they all have in common? They have a website or an app. And the common thing about all three of those features is, all those different features is they have source code. And source code drives that. Imagine if tomorrow you wake up and all the source code is over. Can that person rewrite it? Absolutely, they can rewrite it. Will they have it done in no time? Absolutely not. It will take time. For someone to remember exactly what they had in place is a difficult thing. Not everybody's going to remember that, especially a very complex website. Do you think if Facebook lost their code tomorrow that they would be able to recuperate? They would go out of business. Yes, of course, they made a lot of money and whatever, but it'd be a sad story. Source control is the key to it all. And it allows you to keep a robust of history, allows you to retain this information over a period of time. It's very beneficial for you to be able to go back in case you made a boo-boo. If you move source code into a certain environment, you have to go back. It's easy. It's nice. So we'll talk about what exactly that is. So, I already said that. These guys are 4 different systems that I thought would be important to tell you about. Mainly 2 of them are very popular. One of them is, well, not that popular. The other one was the bomb at one time. So the one that was super popular at one time was Subversion. It is similar to Git, a little bit similar. Miracle is still being utilized a little bit, but not much. TFS stands for Team Foundation Server. It is actually pretty awesome. I like it personally. It's a Microsoft product. It could do a lot of powerful things that Git itself can't do. It's also built off a project management tool. Git is my one that I like, and that's the one that we'll actually use in this class. The reason being that I use Git is because Git is probably used out of 90% of companies. So you get a job tomorrow and you tell them that you know how to use Git, that right there might be the way that you get into that job. It is essential that you have that skill set. You'll find out, like anything else, everybody does it differently. But if you understand the basic concept of it, how to do it, you can easily learn someone else's environment. So what is Git? Well, it's a distributed version control. It coordinates work between multiple developers. So if you're working on a project in a class and you have 4 people in your group and each person is either working on a different feature of that same page. So let's say that we have Snapchat. So Snapchat always has those different things that you could do to make yourself look cool or change your face or whatever the case is. But those are features, and you could have that one app and you can have multiple people work on different apps. So like, especially like a holiday around the 4th of July or Labor Day or Christmas, they have all these new ones out. Each developer may be working on one. Now the thing is that the code might be in a single unit location, but each feature is outside. So this allows people to work together on multiple features to put that app out. Who made the changes and when? It allows you to revert back to a previous time. So let's say that you pushed it to production. I've seen this happen too many times where something's pushed to production and, oh my gosh, we didn't see this happening. And guess what happens? Yeah, absolutely. It gets reverted back to another time and until it's stable. And then you have your local and remote repositories. And that's that information right here I just told you about. Concepts of Git. It tracks code history. Takes snapshots of your files. You decide when to take a snapshot by making a commit. So commit is when you're committing to a relationship with your girlfriend or boyfriend. You're committing to something. You're committing to a job. Those are all what commit is. You could visit any snapshot at any time. And you could stage your files before committing. So that itself is, and making sure this is recording because I did this too many times where I think I'm recording and I'm not. So you can stage your files before committing. And then if you stage them and you're like, oh my God, I can't do that, you can unstage them, not a problem. So editors, let's talk about editors. These are tools that you use to edit Git. Git is what we just explained, but in order to do it, you need an editor. Git Bash is commonly used if you're using a Windows computer or a Linux computer. Well, let's not say Linux, a Windows computer. The one in the middle here is that I'm showing you is Terminal. That is commonly used on a Mac. So right now I'm using a Mac. So if you go up to the part in the search bar and type in Terminal, it'll bring up that emulator. And then lastly is SourceTree. SourceTree is a tool written by a company called Atlassian. And Atlassian has a tool called Bitbucket, which is a form of Git, but a different type of Git, but the same concept. And SourceTree is a user interface you can drag and drop, which initially when I learned Git, that's how I learned it. But I ran into so many problems that I couldn't figure out. And ultimately, the best way that I learned was by doing it through command line, and that's what we're going to do in this class. And it allowed me to figure out tricks. It allowed me to figure out issues that happen. It was just so much easier, I thought. So these are three. You're either going to use Git Bash if you have Windows, and if you have a Linux, you're going to use another form of Git Bash, Unix, PuTTY, and in this case, we're going to use Terminal. Commands. Now, I won't go through all these commands. I'll let you kind of read through them. But when we go through the lab, I'll walk through the commands for you. The first one is a way to initialize a local repository. We don't always have to do that. So when I show you in the lab, when you watch the lab, we don't do that, and you'll see why. It just depends if the only time you're going to initialize it is if you are starting from scratch and you're doing it locally and you haven't created a remote repository. So we'll talk about remote repositories shortly and why they're important. You could keep everything locally, but we're going to use GitHub in this course, and that will be our remote repository. Git add, we'll show you in the lab how you can add multiple files, or I'll show you how to add a single file. Status allows us to easily see, is that file staged or not? So when you type in git status and you're in the repository, it'll either be red or green by default. Green means that it's staged, red means it's unstaged. Commit means that you are committing your messages, what you're pushing to the index. Push, two things happens here. If you just do a git push, it will push your changes to your local environment. If you do git push space origin, then it pushes it up to that remote area, whether in this case it'll be GitHub, but it could be SourceTree, it could be Bitbucket, it could be GitLab, but in our case it'll be GitHub. And then git pull does the same thing. Git pull is very important. I always learned this term a long time ago. Always get the latest and greatest. What that means is if you're a software developer, you come into work and you need to grab your source code, no big deal. If you're working on a group project, always go out and right click on it and get the latest or greatest, whatever the case is. A very popular guy by the name of Mr. Von Gray taught me that a long time ago, and something I never forgot personally. So I definitely would recommend it. So moving on. So what we need GitHub and Git. So in this case right here, I need you, if you haven't already, you need to go out to git-scm.com and download Git, and then also go out to github.com and download that information as well. That's very important. And we'll walk you through the lab how to do that as well. So you want to learn more? Awesome. Go to my website, jseaman.it.pointpark.edu. I have some icons over here, which has a YouTube icon. I also have a way that you can schedule a meeting with me. But this is a summer course, but if it was an in-person course, you can schedule a meeting with me on the hours and days that I teach. All right. Software architecture. So in this one, I thought it was very important. We're going to talk about SDLC, waterfall, agile, continuous integration, and continuous deployment. And those are all things that we're going to follow in this class to a degree. So what is SDLC? Systems Development Lifecycle, Software Development Lifecycle. It's just a lifecycle that you follow in order to do something. So what's it mean? It's a process followed by a software project. So when you work in an industry, it's not about writing code. I mean, it is, but you have to follow a project. And within an organization, it consists of a detailed plan describing how to develop source code, how to maintain it, how to replace it, how to change it, and enhance it. So you have to follow all those phases, and they come with some type of discussion. So as you see here at the bottom, they start off, one is requirement and gathering. And I think we talk about that, just to double check. Yeah, I'll go into that right now. So you have the development process, which is, I'm kind of going through here. Okay, I think I talk about it here, planning requirement analysis, system design. Okay, I'll just make sure I get it. So you have the requirement gathering and analysis. That's when you're getting requirements from the client. What does he or she want? We'll talk about the design process, the implementation and coding aspect, integration, deployment, and the maintenance. So let's move on here. So that is, let's see, actually, let me kind of talk a little bit about it before. Requirement gathering and analysis. So what is that? So customer comes to you and says, hey, I want this project. I want this app built. I wanted to do everything that Flappy Bird does, and I want to do better. And I want to make a lot of money, and I want to retire. You'll hear a lot of that stuff. So that is when you're getting all the requirements. What does he want his site to look like? What does he want to happen? What is his requirements, etc., or her requirements? The design is you're designing what it's going to look like. So if hopefully at this point everyone's seen the movie Social Network with the guy that played Zuckerberg, where he's designing Face Smash in his bedroom. Well, that right there is a design method. It's not as cool as that, but you're actually sitting there designing it. A lot of times what happens is you have these meetings with people, you're designing on a whiteboard, you're drawing out what your screen's going to look like, then you start talking about what code you're going to use, or you can use JavaScript, you're going to use jQuery, or you're going to use Knockout, or you're going to use AngularJS, what type of background are you going to use, what type of framework, what type of design. All this stuff happens in the design session. The implementation and coding, that is how, when you're implementing your code, you're actually testing your code, you're writing the code, you're implementing it into the process. Integration and testing, you're integrating your code into your servers, your server environments, and making sure that it works. Number 5 is your deployment. You're setting up a deployment process. How are you deploying it to the servers? How's it getting out there? Is it automatic? Is it manually? And lastly is your maintenance. You have to have a way to do maintenance. You're not always going to have code that runs all the time. You're always going to have a change. It's something to think about. An enhancement, at least. So the first SDLC, there's multiple ones, but the ones that we'll talk about in this class is waterfall and agile. So what is waterfall? It consists of system engineering, analysis, design, code, testing, and maintenance. Just everything that we kind of talked about here. Actually, everything there. But I will tell you, here's the thing. Waterfall is a slow process. It is like watching paint drip down a wall. I am not lying to you. I am absolutely serious about this. It is a slow process. It could be a 9-month process. It could be a 2-year project. It could be a 5-year project. It could be forever. The thing about this, it's just the way that it's scheduled. These different tasks that are happening here happen in different periods. The downfall of doing this, let's say that that person came to you and says, I want this Flappy Bird app, and I want it to do this and that. I want it to just blow the world apart. So here we are sitting at 18 months. We are finally finished the coding, and we are testing it. The client is finally getting it, the ability to look at it. And he or she is like, whoa, this is not what I want. I want that new app that's out right now. I want that new Angry Birds app. So at this point, they've changed your mind, and you've already wasted 18 months or whatever the case is. And then you have to go back and redo it. It just never ends. And plus, the thing is, they're losing money out of their budget because they invested X amount of dollars in this budget, and now they're looking for something for free. So that is the downside of waterfall. So walking through it, the planning and requirement analysis, this consists of a lot of meetings. Usually the people in these meetings are your project manager, your business analyst, and your software developers. It's just constant back and forth. System design, that's, you're specifying what your design is going to look like. Some cases you have an architect. Some cases it's your lead software engineer or software developer. He or she will come up with hardware, like how many servers are going to be involved. Are we going to run load balancing on the servers? Are there going to be multiple servers? What's the disaster recovery going to look like? Is this going to be Azure or what do you call it, Amazon Web Services, or is it going to be on premise, or is it going to be both? These are things that you define. What type of database are you going to be using? Is it going to be a shared environment, which is free maybe? Is it going to be a dedicated environment that's not free and it costs a lot of money? Those are things that you have to think about. You have to think about what you want to do, and then you have to go back to your PM and see if it's in a budget. Testing. This is when you have your code out there, you're ready. It's in some environment, whatever environment you have set up. If you have a development, a test, a QA, a prod, or maybe a development staging and prod, whatever the case is. You have these environments set up, and you have to test your code to make sure it works. And that's usually your QA person. Deployment, how is the code going to be deployed from server to server? Once it reaches an environment, how does that work? Are you using a third-party tool like TeamCity or Team Foundation Server or Jenkins? These are tools that can automatically deploy stuff for you. Maintenance, you have to be willing to figure out what maintenance you're going to run. So maintenance is patches that are released. How are you going to attack those patches? Are they going to be in a change management process? Those are things that you have to consider. All right, so let's move on to Agile. Let me have a drink break here. Going strong at 17 minutes. On through here, guys. Play from current slide. So what is Agile? Oh, well, Agile is different. It's quicker, it's faster, but it's a fast-paced environment. If you can't do Agile, at first it was too much for me personally. It was a lot to take on because it was just quick, and you just have to get used to it. But once you get used to it, it just becomes second nature to you. So different things happen. You still have the same players. You have a project manager, but their name is called a Scrum Master. You have a business analyst. Their name is called a product owner. But everyone else is the same, your developers and QA and so forth. So you have something called a product backlog meeting. And this normally is everything that you want to accomplish. So let's say that person comes to you and says they want the kitchen sink and all with it. So what is everything they want? So now you have to take all their notes, figure out what they want, and you have to create a backlog, which is tasks, individual tasks of what is going to happen. Create a button, have the button create an action event. We need to create a feature or an API call or a database call. We need to do this. We need to do that. That happens in the backlog. So you might have 100 different tasks, and that's fine because what you want to do is put everything in this backlog. It's not going to happen overnight. It'll take a period of time. Then you have a sprint backlog, and this is a sprint is normally conventionally 2 weeks long. Some companies like to do 4 or 6, and to me that just throws a wrench in the game. Typically, I say stay with two weeks. You have 2 weeks to work on something, and you're not going to have everything. So let's say you have 100 items in your product backlog, and you look at it, and you start from scratch, and and you go through maybe 5 things, and when you guys talk out, you're like, these 5 things, I think I can accomplish that. That will go in your sprint backlog, and that's what will be worked on within that 2 weeks. Now, remember, some environments, they will crucify you if you don't have it done in 2 weeks. Other environments are a little bit more laid back. Then you have your sprint cycle, and then your increment and your meetings and so forth, and we'll talk about that. So tasks are divided into times. Boxes deliver specific features for release. The approach is taken in working software build in a different iteration. So for example, you see all these people involved. You have the Scrum Master, the product owner, developers, the QA, and so forth, and they're all working together. It's kind of like a circuit, So in Agile, you have planning, requirement analysis, designing, building, and testing. Same thing as waterfall, but different time frame. So these iterations are known as sprints. Typically, sprints are 2 weeks long, like I mentioned. Sprints are a duration that you have to complete your working during that period, and this includes unit testing. Sprints are usually broken down in a point system by hours, duration, and capacity planning. So typically when you're doing this, you have to tell your person how much time you have to work on the project. So you got to think about it. You have 2 week sprints. That's 80 hours, 40 hours a week. You tell them right off the bat and say, you know what? I'm working on another project, so I can only devote 50% of my time. What that means is you can only do 20 hours per week. So it's 50% of your time. So anything that they assign to you, you can't go over 20 hours. But you got to be careful here, because it'll be up to you to decide, hey, this task right here, I think it'll take me 4 hours. But in reality, you're thinking, if I hit this bug or do that, I run into that situation I did a couple months ago, it might take me 8 hours, but I'll just tell them 4 hours anyways. You don't want to do that, because if you lie to them and tell them it took you 4 hours and it took you 8 hours or 10 hours, they're going to give you tasks like this all the time, and they're going to think that you can get those done. I've been in an environment like that, and it will backfire you, and it will backfire real quick. So it's important to double your time. So if you think it's going to take you 4 hours at best, tell them 8 hours. So that right there, you got 8 hours and you have 12 hours left to work on something else. But you got to be careful, because it's always good to double in case something takes too much time. So then you have these ceremonies. You have a planning meeting. You have a daily huddle stand-up meeting. At the company I work at right now, we have a daily stand-up at noon every day, which is noon my time. It's most of the people in my group are in different regions of the country or world where they're either 3 hours off or 5 hours ahead or an hour ahead or whatever. So we're all meeting at different times, but we're talking about what we're working on. So at the daily huddle thing. So when you have the daily meeting, you talk about normally what are you working on, what will you be working on, and do you have any blockers, any problems that are stopping you from doing what you have to do. There's the backlog and grooming meeting, and then there's the retrospective meeting. So this right here is an example of a Scrum cycle, from sprint planning to backlog and so forth. So it paints a little picture of how busy it is. That's exactly what it is. It's mayhem at first, but then you get used to it, and you either love it or you hate it. So planning meeting is when you plan what you're going to accomplish in a sprint. So it's Monday morning. You come in, you have your meeting, you have your coffee, you have your bagel or your stuff from Dunkin' Donuts, and then you plan your planning meeting at 9 o'clock in the morning. Typically, this consists of all the people I mentioned, and then maybe the business. And typically, this could be a 2 hour to 4 hour meeting. 2 hours is with the business, and you guys are talking about what you want to accomplish in this sprint. And then the next 2 hours is the business is not there anymore, and you're focusing on, okay, here's the backlog, here's the items that we're going to work on, and then usually you're designing these on the board here, because you might be in there for 2 or 4 hours, and you're designing them on the board. You're talking about what's going to be implemented, what do you think is going to happen, what code are you going to use, do you think this is, and you guys decide a point system. Is this a 2 points or up to 20 points? And you give it points. And these points are the difficult. So let's say it's a huge thing and you're like, this is definitely 20 points. You put 20 points and you save the big stuff for last, where you could take that and separate. You could take that big stuff and you can we call it. You can obtain it from other people. Other people can help you out and get the small stuff done first. So this planning meeting is 4 hours long. So at this point, you've accomplished nothing. Monday's over and it's ready to start Tuesday. So then you have your backlog meeting. This is when the Scrum Master and a PM needs to, with the product owner, to go over the project. This is when they work on the backlog for that sprint. And they're like, hey, these are items that we think can be accomplished. Let's add those in here and so forth. I will talk about it because I didn't say anything about it here. I thought I did, and I'll go back. So I talked about, so it's Monday, you have your planning meeting. So you actually start working on your code on Tuesday, Wednesday, Thursday, Friday. So that's 4 days right there. Those 4 days are 8, that's 32 hours. Now, if you're that person that has 50 hours, your day's pretty much over, your week's pretty much over because you've already utilized your time. The following Monday, you work on your code. Tuesday, you work on your code. Now, it depends on your company, but places I've worked at, we set at noon on Wednesday is our deadline. So we had to have all our code in by noon, which in reality, we had Tuesday, Wednesday, Thursday, Friday, which was 4 days. If you had 8 hours a day, that was 32 hours. And if you did have, and you had half of it, you had to really mess your time up because then you had Monday, Tuesday, so that's 7 days, which was 8 is 56 hours. And then Wednesday, you have 4. So you have really 60 hours in reality. And that you have to allow the QA person to actually look at your code so that he or she can make observations and say, change this or this doesn't work. And it allows you time to utilize your other time on part of Wednesday, Thursday, or Friday to finish it. Like I said, daily huddle shouldn't be no more than 15 minutes. Retrospect meeting, that meeting's important because that is on the Friday of the second week of your sprint, the last of your sprint. You meet with your team for maybe an hour, and you guys talk about the good things that happen in the sprint, and you also talk about the bad things that happen, and you also talk about, most important is, what are you going to do to improve moving forward. It's always a way to talk about good things, bad things, and how we're going to get better. That's it. And you do that every retrospect meeting. All right, so let's talk about continuous integration. So it's a development practice that requires developers to integrate their code into a shared repository several times a day. Each check-in is where a verify and automatic build. Now, this is only if you have automatic build set up, such as Jenkins, TeamCity. Now, when you watch my lab, how we will do it, we will have a repository set up, and we'll have a hierarchy above the repository. What will happen is every time that we are working on code, or you are working on code, you will then go into the command line, and I walk you through how to do this, and you will move your code to the repository, and that's where you'll start checking it in. That is our way of doing the continuous integration. We're always moving it in there, checking it in, and going back and coding and checking in and so forth, because now you're creating an iteration, you're creating a path, you're creating a audit trail. This right here is continuous integration. It's constantly happening. People are constantly doing it. So what normally it works, it's like Dropbox or Google Drive. Once a file is dropped there, it is then moved somewhere else in the cloud. And that's how integration works as well. In our case, we're doing manual. I talked about writing some shell scripts and automating it, but that's not this class. But you get the gist. This right here kind of walks through how all this works automatically, which is pretty important. Check-in, this is a step when a developer checks their code into the source code repository or branch. Example would be a dev branch, and we'll talk about other branches. We're actually going to use a feature branch in order to do our process. And you'll learn about that in the lab. CI application will detect that if source code has been added or merged into the source code and automatically build an application. These tools can consist of DevOps, TeamCity, Jenkins, etc. So those are different tools that you can use, which I mentioned. CI application, it's a way to build the application automatically, test it, and move it forward. Let's see here. That's fine. I don't know why it's the same thing. This is just telling you more information about the CI application. Continuous deployment is same thing. It's kind of like this guy right here. It's like DevOps. This guy's pushing over the wall. The developer's like, all right, I don't want it anymore. You take it. I don't care what you do with it. But usually it's an automatic automated piece. This is when continuous integration and deployment play the same role together. So here's how it works. Integration, it goes to a location, sits out there. You either have it scheduled to pick up automatically, or you have it scheduled at 5 o'clock at the end of the day. It moves into environment, pushes it up, it moves into that environment, and the next step is to take that code and deploy it to a server like this. He's manually pushing over the wall to DevOps, and they're like, okay, I'll load it. Or if it's automatically, it'll be pushed up to that server, and now it's on that server, say the QA server or dev server, and someone could easily just go out and check it and start testing it. That's continuous deployment. And this is an example right here. Code developer commits the code in the Git, it pushes it, builds it, uses say TeamCity, no version artifacts, then it pushes a QA. In this case right here, it's using CenterCube, which is a security. It's a software that checks your source code and moves it to the pre-prod, and then eventually it uses Docker and deploys it automatically, or if you have a system schedule. So this is awesome stuff, and this is where you want to get to eventually. This environment consists of development, QA, unit testing, and production. Like I said, everybody has a different environment. I've worked at places just have staging and prod, or dev staging and prod. And that's it, guys. That's the end of this week 1 module. There's a lot there. There's a lot to consume, and we will use every single one of it, and you'll have to show me each week as we move on with the project. So thank you for your time, and you guys have a great day. I'll talk to you soon. Bye.